Welcome, ladies and gentlemen. We are officially starting Chapter 5. We are learning how to solve systems, which means more than one equation. In 8th grade, we do two equations. Or, if you notice right there, I can graph two linear equations and find the point of intersection. So again, in Math 8, we focus on two equations. We got a few strategies on how to solve. Today we'll be focusing on graphing. And the great news is you have learned a lot of strategies on how to graph linear equations. You've got your intercepts, you've got a data table, and of course you have your slope-intercept form. The point of intersection really means where the two lines are going to cross. When you graph, you have three possibilities. The two lines will intersect, like I just showed you with my arms. The point of intersection is the answer. Maybe that's like 3, comma, -1. That's where they actually cross. Or you might have two lines that are parallel, so they will never cross. Therefore, it's a no solution answer because there is no point of intersection. And then the third possibility is that actually both lines are really the same, because when you go to graph them, you would only visually see one line on the graph, which means since they are the same line, they have infinitely many solutions in common. So there's not one point of intersection because they're not two separate lines. Before we get to our actual graphing, we want to talk really quick about your strategy to see if the point that's identified really is a solution or no solution, meaning is it the point of intersection? And it really just comes down to guess and check. But instead of guessing, we have actually given you the answer that we think might be the point of intersection. And you simply need to remember that on that ordered pair of 5, 3, that the x is the 5 and the y is the 3. So when I go ahead and do my quick substitution for my first line, 2 times 5, subtract 3, I do my little bit of 6th grade, 7th grade math, and I do get 7 is equal to 7, which means that is checking out for my first equation. But in order to truly be the point of intersection, it also has to work for the second equation. So when I go to look at the second equation, x plus y is written as 5 plus 3. Ooh, unfortunately, 8 does not equal 2, which means 5, 3 is not the solution. It's not the point of intersection. Now, this does not mean that they are parallel lines. It just means that 5, 3 isn't the answer. So if it was a multiple choice problem, you would guess and check again. But again, on your homework, we give you the numbers to work with. So let's try this one. Example B, same strategy. Look at your ordered pair given to you. The -4 is the x, and the y is -1. So on my first line, I would write it as -5 multiplied by -4 and plus -1, because again, it's just plus y. So I do my 6th grade, 7th grade math. -5 times -4 is 20. And instead of plus -1, I can just really write subtract 1. That checks out. Now again, the first one checks out. That's excellent, but you cannot assume that is the answer. You need to also check the second linear equation because they both have to work to be your point of intersection. X subtract 7y will be written as -4 subtract 7 multiplied by -1. So -4 stays the same. And then the center, -7 multiplied by -1 is really a plus 7. -4 plus 7 using our integers, it does work out. Since both of them work, that means that this point is the solution. That is the point of intersection. That's where the two lines will cross each other. So on a multiple choice test again or a quiz, you would select that as the answer because that's the one that works. And it works for both. That's the key idea. So when we do some homework problems together, you want to see if it works for both. All right, now let's get started on the main idea. Now again, if you fall behind on the notes, you can just back the video up. You could also use a strategy on a website that I'll share with you to see if that helps. All right, graph the equations on one coordinate plane to identify the point of intersection. Now, you've got two ways, I would say two basic ways to graph, even though we can use our data table. You can use your intercepts. Some of you are really amazing at that, but I'm going to suggest that most of you will be using your slope-intercept form. Once I graph it, I'm going to test it to see if it truly does work. Kind of like what we did on example A and example B. All right, slope-intercept form. My first equation, I want y equal. So in other words, I got to move my 2x to the other side. I do that by subtracting. And if you notice, I have y equals, which means I get to stop there. I don't have to divide because my goal is to isolate y. Y is equal to. So my slope is -2 or -2/1, and b is 2, or really, let me see if I can fix it with my pointers option. Remember, we said it was the ordered pair, 0, 2. Wow, that's kind of messy. So when I go to plot that information, I can make my line starting at 0, 2, and then it's a downhill line because it has a negative slope. If you notice, this is just repeat information from chapter 4. My second line, use a second color. You can put some 1s there to help you out if you'd like to. So I'm going to subtract 1x on both sides. And I'm going to divide by -1. So let me put some 1s here. Subtract 1x, which gives me -1y is equal to -1x plus 4. I divide everything by -1, so that gives me y is equal to x subtract 4. My slope is a hidden 1, or 1/1, and my y-intercept is -4. The ordered pair, again, is 0, -4. So that means my line would start out at 0, -4, and then would go uphill. Up 1, right 1, up 1, right 1. So now that I have both lines ready to graph, I'm going to go to the coordinate plane that they have in common. My first one, again, starts out at 0, 2. Got my starting point, and then it goes down to right 1. Down to right 1. Make my line and the equation. Now again, if I've done it correctly, I believe my second line should intersect or cross with the first line, and I'll be looking for the point of intersection where they actually cross. My second line starts out at 0, -4, and then it goes up 1, right 1, up 1, right. Oh, look at right there. They share an actual point. The blue went on top of the black dot. So I'm going to, right here, next to that actual point of intersection, I'm going to put what I think is the solution. The point of intersection appears to be starting out at the origin. Let me change my pointer. Starts out at the origin, goes right 1, 2. So x is 2, goes down 1, 2. So y is -2. So I think the answer is 2, -2. But remember, sometimes our graphing might not be the greatest, so we're going to go ahead and test that point. By testing it again, I'm going to go ahead and do it like example A and B. I'm going to substitute x is 2, y is -2, and see if it works for both equations. So my first equation, 2 times 2 is 4, subtract 2, yeah, that definitely works. Second equation, x subtract y, 2 subtract -2, which is really 2 plus 2, so it works. That means my answer really is 2, -2. So on the multiple choice, maybe it's answer A, and I select answer A. The testing, again, is really just a good test-taking strategy, and we've tried that when we did one equation. Now we're doing 2 equations with 2 variables. All right, another one. First line looks pretty good. Second line looks excellent because if you notice, the second line is already y equals. So I really just need to rewrite my first line. So if you'd like to, let's put some 1s in front. So it means I'm going to subtract 1x on both sides. But I really don't have to divide by 1 because 1y is just y. So that means I have y is equal to -x plus 2. Again, I don't put the actual 1 on that answer there. My slope is -1/1. My y-intercept is 2, or more specifically, 0, 2. Second equation, again, was already good to go. It's already in slope-intercept form. Y is equal to x subtract 4. Slope is 1 over 1. Y-intercept is negative 4, or, again, 0, negative 4 is the correct identification for the y-intercept. All right, quick graphing of that information again. The first line was going downhill. Yep, negative 1 over 1. So it starts out at 0, 2, and then down 1, right 1. Down 1, right 1. My second line starts out at 0, negative 4. Up 1, right 1. Up 1, right 1. Now, if I make an additional point, up 1, right 1, it might get a little bit better for you to actually see right here. So that's what I try and advise students is maybe put more points right here, a little bit better visual. That is the point of intersection. And again, that tells me to start at the origin. So that's right 1, 2, 3. So x is positive 3, down 1. So that means y is negative 1. So I think the point of intersection would be 3, negative 1. Again, all I'm asking you to do is graph two lines, see where they cross. So if I test 3, negative 1 on my first equation, it's just 3 subtract 1. So yeah, that definitely works. Second equation, y is negative 1. 3 subtract 4 does give us negative 1. So that is the solution. Excellent. So we're going to come back together for some homework help, and I will show you a website that's very helpful. Maybe show you some resources on where you can actually print out some worksheets as well to help you be able to graph. All right, be awesome.